Okay, now in this presentation, we're going to start talking about what we call the average rate of change, which is coincident with your topics presented in section 3.3. So the average rate of change of a function on a given interval is this. So here we have some arbitrary function, f of x, okay, got chopped off here, but doesn't really matter, okay? So when we're asked to compute the average rate of change on this function from on the interval uh, from a to b, interval from a to b, that's the left point of the interval is a on the x-axis, okay? B is the right point of the interval on the axis. Then if we come up and say, okay, what is the corresponding point on the function? Well, then it's, a comma f of a. If this is, it looks like close to -1, so if that is -1, when we put it in, we get out something a little bit higher than 6. So a f of a is correspondingly the coordinates, generally speaking, for this point. Okay, I don't want to put specifics, I want to keep it very general. Likewise over here, okay, the point on the function whose x coordinate is b would be b f of b. The average rate of change is asking one thing. Find the slope of the line. Find the slope of the line between the 2 points, in this case a f of a and b f of b. That's what average rate of change is. It is the slope of the line between 2 points on a graph on a given interval. So the slope interval, the slope computation is the difference in y's over the difference in x's. Okay, the difference in y's is f of b minus f of a over b minus a. I could likewise had said f of a minus f of b over a minus b. It would compute the same. Okay, so that's the setup for the average rate of change. Again, just on some interval in a given function, find the corresponding y coordinates of the on the interval. Okay, so we have the 2 points, a f of a and b f of a, and a f of a and b f of b, and then we're trying to find the slope between those two. Okay, so let's look at a particular example. All right, we're asked to find the average rate of change on a given function on the interval a to b. Okay. As I said, the interval implies from x equal a to x equal b, which implies the points a f of a and b f of b. Therefore, the average rate of change is computed, okay, in this sense. Now, here's a particular example. Find the average rate of change for the function x squared on the interval 2 to 4. Here's a graphical look at it. Here's obviously our graph of x squared. Our interval is from 2 to 4. We want to go and find if the interval is from x equal a to x equals b, or in our particular example, x equals 2 to x equals 4, then the corresponding y coordinates, as you can see, would be 4 and 16. So we're back, and again, what we need to do is find the slope of this line. Basically, the slope of the line between the points 2, 4, and 416. Because as we can see here, okay, all right, that is the corresponding y coordinate. So just compute the slope of that line. F of b minus f of a over b minus a, as the formula prescribes. Difference in the y coordinates, 16 minus 4, over the difference in the x coordinates, 4 minus 2. Computing that out, as you can see, we get this the slope of that line, or if we will, in the terminology we're now using, the average rate of change is 6 units. Okay, that's the slope. Okay, let's look at another example per se. Okay, physics will tell us that there's equations of motion. So if an object was thrown straight up, then it's going to be under the influence of gravity, and the height to which it will rise will be governed by this equation. So this equation is S of t, where t is the variable time. So, and S is the position. Where will it be? How high will it be as a function of time? So, so this is the particular equation. Again, we're just using a different function notation, S of t rather than f of x, just because our variable, the independent variable in this case, t, is time. So that's just a formula, okay? And what we're going to be asked to do is, as we said here, t is measured in seconds, s is the distance above the ground, okay? And there's the graph of that. And what it's asking us to do is find the average velocity of the object in the first 3 seconds. Now, average velocity is particular special application of the average rate of time, because it is the average rate of time, but applied to this situation, in this real life situation, it is called the average velocity. So if we're computing what we call the average velocity over the first 3 seconds, that is the same as computing the average rate of change on the interval from 0 to 3. Okay, now of course then that implies that we need to find the slope of this blue line as shown here, and we need the points to find the slope. So the coordinates, of course, at 0 is also 0. At 0 time, it's not off the ground, so its height is 0. At 3, or at 3 seconds, we can throw the value 3 in here and do the computation, and pick up that the value of the coordinate, the y coordinate at t equals 3 would be 240. So computing the average rate of change, the slope of that line, the difference in the y is 240 minus 0. We're just going to these coordinates here and figuring that out. 240 minus 0 over 3 minus 0, or 80. And since this is in units of feet per second, which are velocity units, so therefore it computes for us the average velocity, as it were. Okay. All right. I think we're going to stop it here and resume with a new video.